Hey guys, let's get our mind off all this crazy coronavirus stuff and talk about some transmissions. I'm using the book. It's Modern Diesel Technology Heavy Equipment Systems. If you have it, it's chapter 11. If you don't, I'm going to show you the book as we go here and just talk about it. Talk about what it's used for, talk about how it works, and see where it goes. So here we go. So this book starts out with the 4-speed Powershift transmission used in backhoes and wheel loaders, some bulldozers. So why not just use a manual transmission? Well, it's quicker to use a Powershift transmission for forward and reverse gears. So why do we need it to be quicker? Well, various reasons. Everybody wants things to be quicker, but in this case it would be to get the job done quicker, especially with wheel loaders or backhoes or whatever. You're going to be doing a lot of forward and reverse movements. So the way they do that is just like an automatic transmission in a truck. Clutch packs controlled by hydraulic pistons. So I've got a diagram here in the book, and this is of a 4-speed Powershift transmission. Powershift transmissions can use either a countershaft, like you see here, that's like a manual transmission. You can also have Powershift transmissions that use planetary gear sets, just like your automatic transmission in a truck. This example, however, is a countershaft transmission. So at the top of this diagram here, it shows us the clutch packs. We've got a forward clutch pack and a reverse clutch pack. So, and then you see all the ports in the shaft there. That's where our fluid's coming from. So the clutch packs forward and reverse are applied through these fluid ports, whichever fluid port feeds whatever clutch pack, to apply the clutch pack for power to come in from the engine and ultimately make it out of the output shaft. So how does it do that? Well, it's got a valve body just like a truck. Typically a valve body these days has a solenoid pack that controls where fluid's going through the valve body, and applies fluid pressure to whatever port on this shaft to get fluid pressure to the pistons. The pistons, let it focus here, are here and there. So for forward gear or forward movement of the vehicle, there's going to be fluid pressure applied behind that piston or between that piston and the housing. And when we apply fluid pressure between that piston and the housing, it pushes that piston that way. So when fluid pressure is applied and that piston goes that way, well, what happens? We've got our clutch pack. We got frictions and steels just like an automatic in a truck. So when that piston is applied, it squeezes the friction and steel discs together. The steels are splined to this housing. The frictions are splined to this hub, which applies power to the transmission part of it, where we're getting our gear ratios. So while we're up here by this clutch pack, we'll talk about the reverse side of things. So it's the same way. We have a piston, we have the clutch packs, frictions and steel disc, frictions applied or splined to the housing, and the frictions splined to this hub. So when it is in reverse, it uses the reverse idler to reverse the rotation. So, but we'll use forward as an example first. So we've applied the clutch pack here for forward gear by using whatever selector that the operator has in the cabin. A lot of the times, like John Deere, they use a shifter on the stock, like you know, you've got forward, neutral, and reverse right below the steering wheel. So, and then they'll have a gear lever somewhere else to actually select the different gear ratios in the transmission itself. So when the forward clutch pack is applied, it powers that hub, and that hub transmits power in the rotation necessary to spin the output to where it's going to turn whatever the final drive is to make the vehicle go forward. And we'll get into in a later video, we'll get into what happens in the valve body to get that fluid pressure to the piston. But you can only get that speed of going from forward to reverse out of this type of application where you've got fluid pressure applying a clutch pack. Because all that has to happen to go from forward to reverse is, say we're in forward, we have fluid pressure behind this forward piston. Well, to go to reverse, we hit the selector in the cabin, and the valve body relieves pressure out of the forward piston and applies pressure to the reverse piston. And so that can happen very quickly. So looking at the John Deere here, like we were talking about, on the steering column we have the reverse, neutral, and forward position for the clutch packs, the hydraulic side of the transmission. And then if we look down below the dash, we have the shifter for the manual side of the transmission. So we have first, second, third, and fourth. And if you look at the shifter lever, there's a button to disengage the transmission to select the gear. So we can shift while the forward reverse lever is in gear by pushing that button. And what that button does is deactivates the solenoids in the transmission to take engine power away from the transmission to make the shift in the manual side. So if we go from this diagram, we've talked about the forward and reverse clutch packs. This diagram's kind of deceiving because they're leaving out one key piece to the forward gear here. We talked about how the clutch pack grabs this hub, and what this diagram's missing is the forward gear that drives the countershaft when forward gear is selected. So we're going to go over to another diagram. I think it's on the next page, and they're showing us a power flow. So in this diagram, let's see, they're showing us the forward clutch pack will drive the countershaft is the caption here for this diagram. So in this diagram they are showing the gear that is driven by the hub for the forward clutch pack. So when we have the forward clutch pack engaged, and remember the forward clutch pack is engaged by fluid pressure being fed to the piston behind that clutch pack that's squeezing that clutch pack and connecting this shaft to this hub. That hub is splined to the forward gear that drives the countershaft. And just like a manual trans that we've talked about in the past, and I'll probably do another video so we have it of a manual trans, but from there it's just a manual transmission. So we've got our forward clutch pack engaged. That forward clutch pack is carrying the engine torque coming in through the input shaft, and it's driving that hub, driving the forward gear on the counter shaft, and then the counter shaft carries the engine torque down to the output shaft. The way the engine torque is carried through the counter shaft and out the output shaft is through whichever gear is selected on our gear selector on the manual side of the transmission. So now moving on to the reverse side of things. Again, we're just driving a manual trans here, but the way we're driving that manual trans is through either a forward or reverse clutch pack. So now we're in reverse. So that means the reverse clutch pack is engaged with that fluid pressure being fed by the pump and the valve body, and is feeding fluid pressure behind that reverse piston now. And when that reverse piston is engaged, that reverse clutch pack is being squeezed together. And when that happens, the input shaft is ultimately splined to this hub. This hub drives a gear that drives the reverse idler. Now when we put the engine power through the reverse idler, it drives the counter shaft in the opposite direction of rotation than the forward side of things. So when we go through that reverse idler gear, it spins the counter shaft in reverse rotation, and that in turn turns the output shaft in reverse and out to the final drive and to the wheels. So we can really quickly go from forward with this clutch pack engaged to reverse with this clutch pack engaged. When we're in forward, go over here, we're driving the counter shaft through this gear, spinning the counter shaft in the direction of rotation that we need to drive the vehicle forward. And then when we're in the reverse, this clutch pack is driving the reverse counter shaft, and then the reverse counter shaft is driving or the reverse idler shaft is driving the counter shaft. And then again, we're using that manual trans to drive the output. So in forward or reverse, we have those however many gear ratios we can achieve through the manual side of the transmission. So we've talked about the forward drive and the reverse drive through a Powershift transmission. Well, what about a four-wheel drive application? Because a lot of these pieces of equipment are four-wheel drive. Why? Because we're on terrain that traction may be limited. So we need that four-wheel drive to move the vehicle efficiently. So the way we do that is through a transfer gear or a transfer case, depending on how the manufacturer chose to do it. So I've got another diagram here. It's just kind of showing us an overview of the whole. I think this is a loader. So we've got our power plant, and then the transmission, and then we've got a transfer case here. And what that transfer case does, it splits the power, one drive shaft to the front, one drive shaft to the rear. So in a lot of these applications, we have the option of two-wheel drive or four-wheel drive. So how is that option being chosen? When we're in two-wheel drive, when we hit the switch or the lever that gives us four-wheel drive, what's happening to engage that other axle to give us four-wheel drive? So one way they're doing it is through this guy. Now this is part of the transfer gear assembly, and we have another clutch pack. And that other clutch pack, just like the forward and reverse clutch packs, is controlled by a valve body or a hydraulic circuit controlled by solenoids that's controlling a clutch pack. So in two-wheel drive, this clutch pack here going to the front axle in most cases, this clutch pack is disengaged, meaning there's power coming in here, but until this clutch pack is engaged, that power isn't making it out to the drive shaft to drive the front axle. So when we select four-wheel drive, whether it be a switch or a lever or whatever the driver interface would be for that four-wheel drive, when we select four-wheel drive, that clutch pack is getting fluid pressure. It's being engaged by a hydraulic piston behind the clutch pack, and that clutch pack is being compressed between that piston and most often a snap ring and a pressure plate. Pressure plate being just a thicker steel plate in the clutch pack that's on the opposite end of the piston, and then that pressure plate is held in with a snap ring. So when the piston gets fluid pressure and presses against that clutch pack, it pushes it up against that snap ring and pressure plate, and makes the friction disc and the steel disc essentially one. So now our hub that's always getting power from the transfer gear is now transferring that power to the output shaft up to the front axle. So that's one way four-wheel drive is achieved in this heavy equipment stuff. So we've talked briefly about the hydraulic side. The hydraulic side being what activates those clutch packs through the hydraulic piston. The way the hydraulic pressure is fed to these pistons to activate these clutch packs is through spool valves. And I've mentioned the valve body. Valve body is just an assembly that houses a series of spool valves. A spool valve being a circular valve that moves inside a housing that kind of resembles a spool of thread. That's where it gets its name, spool valve. So when you think about a valve body, don't think of it as this crazy looking ant farm that you can't figure out. It's just a housing with a bunch of spool valves in it. So to simplify it a little bit, we'll talk about the four-wheel drive side of it first, just because on the four-wheel drive side of it, it has just one spool valve. One spool valve that's controlled by a solenoid that activates four-wheel drive. So when you're in two-wheel drive and you want to go to four-wheel drive, you hit the switch or the lever and it activates the solenoid to move that spool valve. When that spool valve moves, the solenoid allows fluid pressure to move that spool valve and connect the circuit to feed the clutch pack with fluid pressure to apply engine torque to the output shaft. So we got our clutch pack and we have the output shaft that goes to the front axle. The fluid pressure that is fed to this clutch pack, or the piston behind that clutch pack, is fed by this spool valve controlled by the solenoid. So when you think about it, that valve body, just think it's all one big housing that has a bunch of these spool valves and solenoids in it. So we've kind of talked about the mechanical side of a Powershift transmission and what is actually transferring engine torque, whether it be the clutch packs or the helical cut gears in the manual side of this Powershift transmission. And we've touched on the hydraulic pistons that activate the clutch pack. So going from there, we can kind of start talking about the hydraulic circuit. And when we think about a hydraulic circuit, well, you have to have a pump and you have to have a reservoir to supply that pump with fluid. And then A hydraulic circuit doesn't work too well if it has contaminants in the fluid or dirty fluid. There's a lot of small passageways and screens and so on. So you have to filter your supply of hydraulic fluid. Then like I've talked about, we have valves, spool valves in this case, and those spool valves can be controlled by electronic solenoids. So that being said, we can start looking at a schematic and kind of figure out what's going on in this particular Powershift transmission. So again, we're talking about a Powershift transmission that uses a traditional manual transmission that uses a countershaft with helical cut or spark cut gears. So if we look at the schematic, just like an electrical schematic, the symbols, you can kind of see the connection between the symbol and what it represents. So we can look at the schematic and right off we can look and say, well, that looks like a reservoir or the fluid pan on your transmission, and yeah, that's the reservoir number 18. If we look, well, reservoir. And then so the other part of the hydraulic system would be you got to have a pump to produce that pressure, because the fluid pressure is what activates the clutch packs, or what moves the hydraulic piston, and the hydraulic piston moves the clutch pack. So we have to make pressure, so we're going to have a pump. That guy is our pump, and you can kind of see some resemblance from that symbol in this schematic to a pump, and it's got a little arrow and it's saying our hydraulic flow is going this direction. So the next thing we come in line with is this guy. That is a filter. It's kind of hard to connect that with what it represents. Doesn't make you think filter when you look at it, but so that's a filter and a bypass valve. And you see over here on the side, it can bypass the filter, and it's a check ball and a spring. That check ball and a spring, it's easy to see that it's a check valve or a bypass valve. So we've got a reservoir, we've got pump, we've got a filter. So now we're up to the point where we have filtered fluid under pressure. So here is our main line pressure gallery here at the top of the schematic. And this first leg we go on goes down to a solenoid. Now when we see a solenoid, we can pretty much assume that we've got a spool valve. And what does the spool valve do? It connects hydraulic pressure to a piston. So if we follow that through, if this solenoid was activated and that spool valve was in the position to supply fluid pressure, we would be supplying fluid pressure to our first clutch pack. That first clutch pack here in this schematic is our four-wheel drive clutch pack. So we'll touch back on that in a moment, but we're going to go back up to our main line pressure here and follow it over, and that is the next component we come to here is a relief valve. And we'll touch on that soon, but we're going to go ahead and keep moving, and we get to two more solenoid spool valves here and two more clutch packs. So when we're talking about a Powershift transmission, I'm already going to say we've ran into our four-wheel drive clutch pack. Well, I'm going to say this is our forward and reverse clutch packs. We've got two solenoids, two spool valves to supply those clutch packs. So, and then from there it circles back around and ultimately ends up back in our sump. But before it makes it to the sump, we reach another component, and that would be our torque converter inlet relief valve. So that's going to control the fluid pressure going into our torque converter. Torque converter being the way we transfer mechanical power into the transmission, or transfer power into our forward or reverse clutch packs and our four-wheel drive clutch pack. So in this schematic we have 1, 2, 3, 4, and 5 solenoids. So we're going to have a transmission control module controlling 1, 2, 3, 4, 5 clutch solenoids. So depending on what solenoids we have energized is going to determine if we're in forward two-wheel drive, forward four-wheel drive, reverse two-wheel drive, or reverse four-wheel drive. So let's just kind of talk about forward gear. So if we were in forward gear, this solenoid and spool valve would be supplying our forward clutch pack with fluid pressure, so we can engage our forward drive to the countershaft. And then let's say we want four-wheel drive, so we're going to energize the four-wheel drive solenoid spool valve, and we're going to supply that four-wheel drive clutch pack with fluid pressure. So now we're driving the front axle with the transmission.